So when I'm looking now at our homework quiz B, if I want to look at number 1, how many significant figures are in 3.15000? The correct answer would be 6. So all these zeros at the end, they count because they are after that decimal point and following numbers. So the reason for having them there is they are significant. So correct answer would be 6. For question number 2, we want to write a number in scientific notation. We have our decimal point at the end there because this is a large number, and we are moving our decimal point over so that we have one number, decimal point, and then the rest of the numbers. Now we have our times 10, and because we moved it over 4 spaces, our exponent is going to be 4. So when you move your decimal point to the left, so you're starting with a large number, those are your positive exponents. But if instead you had really small numbers, so you have a lot of zeros in the front, you would have to move your decimal point to the right. Those would be the cases that you have negative exponents. So this one, it's a large number, moving our decimal point to the left, which means it's a positive exponent. So question 3, we are looking at an addition problem. So when you look at our addition problems, you have to look at what is after the decimal. So this is only true for when we are adding or subtracting. So checking out these numbers, nothing after the decimal point, 2 numbers after the decimal point, and nothing after the decimal point. So I don't care how many numbers are in front, because you can see that this has 2 in front, this only has 1, this has 3. All we're looking at is what is after the decimal point. So when I do that calculation and I get my final answer, I don't want to have anything after the decimal point. So when I type that into the calculator, I get the 154.12, but I don't want anything after the decimal point. So I check out our last number that's in front of the decimal point and decide if I need to round up or keep it the same. So since it's followed by the 1, I can drop off what's after the decimal point, and our final answer for number 3 would be 154, nothing after the decimal point. So in number 4, we have a multiplication problem, so it's a little bit different of a rule. We're looking at the entire number, not what's after the decimal point. So when I look at 97, there's 2 significant figures there. When I look at 31.221, I have 5 significant figures there. So when I do my calculation, I only want 2 significant figures. We go with the lowest number. So 97 times 31.221 gives me that 3028.437. But I only want 2 significant figures. So this problem is going to be a little difficult to put into 2 significant figures. So if you have 328.437, that obviously has more than 2 significant figures. Check out your second number. So it's a 0. Look to the right, and it's a 2. So we want to keep it a 0. We do not want to round up. I saw several of you round up on your quizzes. So if we keep it a 0, that's fine, but now we have 3,000, which is only 1 significant figure because those zeros wouldn't count. How do I get 2 significant figures? Well, could I add a decimal point? Now all of those zeros count, but they give me 4 significant figures. It'd be a lot easier if I could round up and do 3,100. That's 2 significant figures, but we already talked about we don't want to round up. So when you're in these cases where it's difficult because you have too few, just 1, or if you add that decimal point you have too many, it's 4, put it in scientific notation. So anytime you're stuck, that's your go-to, scientific notation. So now if we move our decimal point over, 3 point, anything after that decimal point now becomes significant. So let's just add 1 0. Now we have 2 significant figures, times 10 to the 3rd because we moved it over 3 places. So that's kind of your way to control how many significant figures. Put it into scientific notation. So question number 5 is another one where we're putting it in scientific notation. So a decimal point on the back here. We're moving it over to the left, so it's positive 8.32. So number, decimal point, times 10 to the 5th because we moved it over 5 spots. Notice that I did not include these zeros when I wrote my number out. And this, how they're written right here, they are not significant. So I don't need to include them when I write them out here. Question number 6. We're going backwards of what we did in question 5. Instead of going from a standard number, putting it into scientific notation, we're doing the opposite. So we have to have 516000. And I always like to double check my answers to see if I took this number and put it into scientific notation. 1, 2, 3, 4, 5. One number decimal point. Yep, that matches up. So that is correct scientific notation. Question number 7. So this one I think threw some people off because we have 2 numbers, but they were looking at this as a multiplication problem, which really that was part of the 8.2 times 10 to the second. So it was a number written in scientific notation. So then it's not a multiplication problem, it's actually a subtraction problem, which means we're looking at what is after the decimal. So looking at this first one, 213.0, we have one number after the decimal point. 8.2 times 10 to the second, one number after the decimal point. So when you put that into your calculator, don't forget that this times 10 to the second, you need to use that double E button. So when you put it into your calculator, you would put 8.2, then double E. So you're looking for, at least on these calculators, this one right here. So you got to push second, double E, and then you can put in the number that's after the exponent. So it would look like that. When you get your answer, you get negative 607, so negative 607. But we said we need one number after the decimal point. This doesn't have anything after the decimal point. We still need that one number after the decimal point. So we're going to say 0.0. Now that gives us our one number after the decimal point. Question 8, rounding to 3 significant figures.